It is said the harder you work for something, the greater you will feel when you achieve it. With this thought, I welcome you, my dear Glorians of Standard 10, to another class of science. Greetings of the day and a hearty welcome. Let us now continue with carbon compounds. We call carbon a versatile element because of its ability to combine with many different elements. Due to the versatile nature of carbon, it is able to form a large number of compounds. Till now, the number of known carbon compounds is about 10 million. This number is larger than the total number of compounds formed by all the other elements. It's time then to explore the versatile nature of carbon element. The number of compounds formed from carbon is extremely large. Entire living kingdom is made from carbon. For example, the DNA present in the nucleus is carbon-containing compound. The range of molecular masses of carbon compounds is 10 raised to 1 to 10 raised to 12. Let us understand the characteristics of carbon that make it a versatile element. Carbon has unique property to link with other carbon atoms by strong covalent bonds to form very long chains. This property is called catenation. Due to this ability, carbon compounds may contain open chains or closed chains of carbon atoms. Seen here, we find one carbon atom has linked to another carbon atom by means of a covalent bond. As carbon atom has this unique property to link with another carbon atom by means of covalent bond, it can result in the formation of very big molecules. Here we find a closed chain. A closed chain is also called a ring structure or cyclic chain. Open chain can be straight chain or branched chain. This is the carbon skeleton where no hydrogen atoms are shown. Only the carbon atoms are indicated. This is a representation of a straight chain. In a branched chain, we can find that carbon has branched or linked to another carbon atom in a non-linear manner. Second, two carbon atoms can be bonded by single, double or a triple bond, thus giving rise to numerous carbon compounds. We can have carbon to carbon single bond, carbon to carbon double bond or carbon to carbon triple bond. For example, ethane, we can see carbon to carbon single bond. In the compound ethene, we find carbon to carbon double bond. And in the compound ethyne, we find carbon to carbon triple bond. As the bonding between the carbon atom changes, you find that its molecular formula also changes. Thus, carbon is able to form large number of compounds. Third, as the valency of carbon is 4, which means it is tetravalent, one carbon atom can form bonds with 4 other atoms. This results in the formation of many compounds. Hydrogen and chlorine have valency 1, which means they are monovalent. So when carbon forms a compound with hydrogen or chlorine, you find that there are so many possibilities. This compound form is between one atom of carbon and four atoms of hydrogen is methane. One atom of carbon, three atoms of hydrogen, and one atom of chlorine is methyl chloride. One atom of carbon, two atoms of hydrogen, two atoms of chlorine, methylene dichloride. One atom of carbon links to one atom of hydrogen, three atoms of chlorine is chloroform, and one atom of carbon links to four atoms of chlorine, carbon tetrachloride. Similarly, carbon atoms form covalent bonds with atoms of elements like oxygen, nitrogen, sulfur, halogen, and phosphorus to form different types of carbon compounds in large number. Fourth, carbon exhibits isomerism. It is the existence of two or more compounds having the same molecular formula but different structural formula. For example, butane and isobutane are isomers of each other. They exhibit the property of isomerism. They have the same molecular formula C4H10, but you find that the arrangement of atoms is different. Look at their structural formula. Here we find four carbon atoms linked in a linear form, while here we find that the four carbon atoms, the fourth one is branched. Therefore, the structural formula of isobutane and butane are different from each other. Due to the property of isomerism, carbon is able to form large number of compounds. We will now study classification of hydrocarbons. Hydrocarbons are compounds that are made up only of carbon and hydrogen atoms. Hydrocarbons are subdivided into two main groups: open chain compounds and closed chain compounds. Open chain compounds could be straight chain or branched chain. Closed chain compounds are also called as cyclic compounds. They have a ring-like structure. Cyclic hydrocarbons contain three or more carbon atoms in their molecules. Open chain compounds are further subdivided into saturated compounds and unsaturated compounds. Alkane is the simplest saturated hydrocarbon. It is represented by general formula CnH2n plus 2, where N stands for a natural number and it indicates the number of carbon atoms in the hydrocarbon. The simplest alkane is methane. In a saturated hydrocarbon, all the four valencies of carbon are satisfied by single covalent bond. Thus, in alkane, the covalent bond seen is a single covalent bond. Coming to unsaturated hydrocarbons. When all the four valencies are not satisfied by single covalent bond, then double or triple bond are required to satisfy the valencies. these compounds are known as unsaturated compounds. Unsaturated hydrocarbons could be of two types. Alkenes are hydrocarbons with double bond, and alkynes, which are hydrocarbons with triple bond. CnH2n is the general formula of alkenes. Ethene is an example of alkene. You find carbon to carbon double bond. The molecular formula of ethene will be C2H4. Now, if you apply this in its general formula, so N stands for the number of carbon atom, which is 2. So we write C2, and H2N stands for the number of carbon atoms multiplied by 2. So 2 multiplied by 2 is 4. So thus, on applying the general formula, we find that the formula of ethene is C2H4. In alkene, we find that there is carbon to carbon double bond. Therefore, the simplest alkene possible will have 2 carbon atoms, and therefore it will be ethene. Thus, we understand that ethene is the simplest alkene. Alkynes are hydrocarbons with triple bond between 2 carbon atoms. Their general formula is CnH2n minus 2. The simplest alkyne is C2H2. Here you find that there is triple bond between 2 carbon atoms. Now let us see whether the molecular formula complies with the general formula. The number of carbon atoms are 2. So C2. 2n stands for double the number. So 2n becomes 4. So H4 minus 2. So we write C2H4 minus 2 in order to get the molecular formula when there is carbon to carbon triple bond and it has 2 carbon atoms. We see that C2H4 minus 2 is the same as C2H2. Thus we see that from the general formula, we can arrive at the molecular formula of any alkyne. With this classification, I hope you have understood important terms such as saturated, unsaturated hydrocarbons, alkane, alkene, and alkynes. We will now learn how to draw or write the structural formula of alkanes. We have already learned to draw the structural formula of methane, which is the simplest alkane. Methane has 1 carbon atom. Therefore, in methane, N is equals to 1. Now, on increasing the number of carbon atoms, so let us make N is equals to 2. When N is equals to 2, the name changes, and as it has 2 carbon atoms, the prefix is ETH, and alkanes end with ANE. Therefore, it will be ETHANE, indicating that it comes from the family of alkanes. Therefore, ethane means ETH means it has 2 carbon atoms. ANE means that it belongs to the family of alkanes. Now let us understand how to write the structural formula. To begin with, indicate the 2 carbon atoms by its symbols. We know that carbon is tetravalent, and alkanes have carbon-to-carbon single bond. The single bonds are represented by use of 4 lines. So around each carbon atom, we have to draw 4 lines. Now, 1, 2, 3, 4 is for the first carbon atom. For the second carbon atom, this one is common. One single line represents one pair of electron that is shared. Therefore, this is common for both this bond. So this line is the common one. So 1, 2, 3, 4. We need to represent 4 single bonds around each carbon atom. Since an alkane is a hydrocarbon, the next step, at these ends we will put symbol H. Thus, we complete writing H around each of these single covalent bonds. Thus, we see that hydrogen atoms were placed at each of these open ends. This becomes the structural formula of ethane, and its molecular formula is C2 because 2 carbon atoms, 1, 2, 3, 4, 5, 6 and 6 hydrogen atoms. So molecular formula becomes C2H6. Let us verify if the general formula can be used in order to get the molecular formula of alkanes. Like in ethane, we have N is equals to 2. So we put 2, H2N means 4, twice N means 2 multiplied by 2, which is 4. 2N plus 2, so we get 4 plus 2. C2H4 plus 2 means C2H6. Therefore, we can see that from the general formula, we can get the molecular formula of alkane, that is ethane having 2 carbon atoms. Let's understand how to write the structural formula of the next alkane when N is equals to 3. If the number of carbon atoms become 3, then the prefix is PROP, prop. Prop indicates that the number of carbon atoms are 3. And since it is an alkane, the suffix will be ANE, indicating that it comes from the family of alkane. Now let us understand how to draw the structural formula of propane. To begin with, indicate the 3 carbon atoms as N is equals to 3. The next step is to indicate the 4 lines around each carbon atom. So let's begin with the first one, 1, 2, 3, 4. The second carbon atom, 1, 2, 3, 4. This one is the shared pair of electron or the single covalent bond between 2 carbon atoms. The third atom of carbon, 1, 2, 3, 4. This one indicates the shared pair of electron between 2 carbon atoms, indicating carbon-to-carbon single bond. In the next step, we will put hydrogen atoms at these ends. So on putting down the hydrogen atoms, the structural formula of propane is ready. Count the number of carbon atoms, 3. Count the number of hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8. Therefore, molecular formula of propane is C3H8. You will verify from the general formula of alkanes by putting N is equals to 3, the molecular formula of propane. We move on to the next alkane where the number of carbon atoms is equals to 4. When N is equals to 4, the prefix is BUT. The suffix will be ANE since it belongs to the family of alkane. Therefore, the alkane having 4 carbon atoms is called as butane. Let us now understand how to draw its structural formula. To begin with, we will indicate the 4 carbon atoms present in butane. In the next step, indicate the 4 lines around each carbon atom. And as you can see, 1, 2, 3, 4. Around the next carbon atom, 1, 2, 3, 4. This one is common. This is the single covalent bond between the 2 carbon atoms. Similarly, this line indicates that it is a single covalent bond shared between 2 carbon atoms. 1, 2, 3, 4. For the next carbon atom, 1, 2, 3, 4. Now at these open ends, we will write hydrogen atoms. Thus, in butane, we find 4 carbon atoms, and let's count the number of hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, its molecular formula becomes C4H10. Again, you will verify the molecular formula by using the general formula of alkane. Let us understand the next alkane when N is equals to 5. When 5 carbon atoms are present in the alkane, then the prefix is pent since it has 5 carbon atoms. It will end with ANE since it belongs to the family of alkanes. Therefore, the alkane having 5 carbon atoms is called as pentane. Let us understand how to write the structural formula of pentane. To begin with, let us first put down the 5 carbon atoms. In the next step, indicate 4 lines around each carbon atom. 1, 2, 3, 4. 1, this one is common since it is carbon to carbon single bond. It indicates the shared pair of electron. 1, 2, 3, 4. 1, 2, 3, 4. For this carbon atom, 1, 2, 3, 4. And for the last carbon atom, 1, 2, 3, 4. So there are 4 lines drawn around each carbon atom. Next, at the open ends, we will write hydrogen atom. On putting down the symbol of the hydrogen atoms, the structural formula of pentane is complete. 1, 2, 3, 4, 5 is the number of carbon atoms. Let us count the number of hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, the molecular formula of pentane is C5H12. You will verify its molecular formula by using the general formula. Let us now understand how to write structural formula of alkene. We know that alkenes have carbon to carbon double bond and their general formula is CnH2n. Since it is double bond between 2 carbon atoms, the simplest alkene will have 2 carbon atoms. Therefore, N is equals to 2. When number of carbon atoms are 2, the prefix is ETH in the hydrocarbon. And since it is an alkene, it will end with ENE. Therefore, alkene having 2 carbon atoms will be called as ethene. Now, let us understand how to draw its structural formula. To begin with, we will write the two carbon atoms. Now remember that alkene has carbon to carbon double bond. So before we begin by putting the foods around each carbon atom, let us first put the two lines between the two carbon atoms indicating carbon to carbon double bond. After this, we will put the remaining lines. Thus, the four lines around each carbon atom, 1, 2, 3, 4. For the next carbon atom, 1, 2, 3, 4. These two lines represent the double covalent bond indicating that two pairs of electrons are shared. Next is to put the symbol of hydrogen atoms at these ends. And thus the structural formula of ethene is ready. We find that C is 2 and 1, 2, 3, 4. There are 4 hydrogen atoms. Therefore, its molecular formula is C2H4. You will verify the molecular formula from the general formula. It's time now to understand how to write the structural formula of alkyne. We learned that alkynes have carbon to carbon triple bond and general formula CnH2n minus 2. The simplest alkyne should have two carbon atoms because it is carbon to carbon triple bond. Therefore, N is equals to 2. When N is equals to 2, the prefix of the alkyne will be ETH. Since it is an alkyne, it will end with YNE. Therefore, for N is equals to 2, the name of the alkyne is ethyne. Let us understand how to write the structural formula of ethyne. To begin with, let us put down the symbol of the carbon atoms. Now, since it is carbon to carbon triple bonds, we should not forget that we have to show 3 lines between the two carbon atoms. Around each carbon atom, we need to put 4 lines. So 3 are already put and now we put the 4th line. For the second carbon atom, we will now put the 4th line. Thus, we have a count of 4 around each carbon atom. 1, 2, 3, 4. 1, 2, 3, 4. Thus, we find that there is sharing of 3 pairs of electrons, which means triple covalent bond. Next step, at these ends, open ends, we will put the symbol of hydrogen. Thus, the structural formula of ethyne is ready. We find that there are 2 carbon atoms and 2 hydrogen atoms. Therefore, the molecular formula of ethyne is C2H2. Now that you have studied about alkanes and learned how to write the structural formula of alkanes which have up to 5 carbon atoms, I'm sure you can fill up this table. When N is equals to 1, name of the alkane is methane. When N is equals to 2, name of the alkane is ethane. N is equals to 3, name of the alkane is propane. N is equals to 4, butane. N is equals to 5, pentane. N is equals to 6, hexane. N is equals to 7, heptane. N is equals to 8, octane. N is equals to 9, nonane. N is equals to 10, decane. Now you have already learned to write the structural formula up to pentane and you also know the molecular formula up to pentane. The rest of it you will complete. We had already learned classification of hydrocarbons. We saw that hydrocarbons could be subdivided into two groups, open chain compounds or closed chain compounds. Closed chain compounds were also called as cyclic hydrocarbons. Open chain compound can be straight chain or branched chain. Open chain hydrocarbons are further divided as saturated hydrocarbons or unsaturated hydrocarbons. This table shows saturated hydrocarbons and unsaturated hydrocarbons. Propane is an example of a straight chain saturated hydrocarbon. As you can see, the name ends with ANE, so it is an alkane, which means it is saturated. Propene and propyne are examples of unsaturated hydrocarbons which are straight chain. Propene is an example of alkene, while propyne is an example of alkyne, and both of these are straight chain hydrocarbons. Isobutane is an example of a branched chain hydrocarbon. In isobutane, there are 4 carbon atoms, but the 4th carbon atom is formed on a branch. Therefore, the name isobutane. Isobutylene is an example of a branched chain unsaturated carbon hydrocarbon, since there is carbon to carbon double bond. Coming to cyclic hydrocarbons, which are closed chain hydrocarbons, it has a ring-like structure. Cyclohexane indicates that it is belonging to the family of, it has no double bond or triple bond, and therefore we find carbon to carbon single bonds. Since the name is cyclo, it indicates a ring structure. Hex indicates that there are 6 carbon atoms, and ANE indicates that it is carbon to carbon single bond. Cyclopentane. Cyclo indicates the ring structure. Pent indicates 5 carbon atoms. Now that you have learned how to draw the structural formula, it will be easy for you to write down the structural formula of cyclohexane as well as cyclopentane. Just remember to count 4 around each carbon atom. So put down the 4 lines around each carbon atom. Coming to unsaturated hydrocarbons, cyclic hydrocarbon, cyclo indicates it is having a ring structure. Hex indicates 6 carbon atoms, and ENE indicates that between 2 carbon atoms there is carbon to carbon double bond. So between one pair of carbon atoms seen here is carbon to carbon double bond. So 1, 2, 3, 4. So you can see that all the 4 valencies are satisfied. Next, coming to benzene. Benzene also has a ring-like structure because it is a cyclic hydrocarbon. It is unsaturated, and the speciality here is there is alternate double bond and single bond between 2 carbon atoms. So we have a double bond, then a single bond, double bond, single bond, double bond, single bond. Hence, the formula of benzene is C6H6. Let us now understand structural isomerism. We had learnt about alkanes and we had understood the structural formula of alkane containing 4 carbon atoms, which is butane. This is the structural formula of butane. The 4 carbon atoms present in butane are linked together in a linear form, and this is the carbon skeleton of butane. The 4 carbon atoms could also link in another way. This is yet another possibility where 4 carbon atoms can link together. Here the 4 carbon atoms link together to form a straight chain, whereas this is a branched chain. On joining hydrogen atoms to this carbon skeleton, we will get the structural formula as this. This compound also contains the same number of carbon atoms and the same number of hydrogen atoms. This compound is called as isobutane. Thus, we find that the molecular formula of butane and isobutane is the same, which is C4H10. Thus, butane and isobutane have same molecular formula but different structural formula. The phenomenon in which compounds having different structural formulae have the same molecular formula is called structural isomerism. The number of carbon compounds increases due to the isomerism observed in carbon compounds. That was all for today. In today's class, we have covered pages 113 to 117. A gentle reminder, please do make time to read your textbook. As I now take your leave and say goodbye, here is a riddle to put a smile on your face. Thank you, dear girls, for joining me. Have a fabulous day. God bless you.